Alright, so here's my next topic, relations and functions. This might be enough for the quiz. You're going to have a quiz later on this week. This is going over chapters 4, sections 1 and 2. I might add some more to this, so keep in mind this is like, there might be more added to these notes. But we have 3 objectives here. We want to interpret simple graphs, so be able to kind of describe out in sentences, and we're going to have some worksheets that go with that. Identify functions and find the domain range of relations and functions. So let's look at something here, and I'm taking this example from example number 1 on page 230. You look at the situation. It says the air temperature was constant for several hours at the beginning of the day, then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents the situation. So you're trying to look at this, tell me which one of those best fits that graph. Now if I look at graph A, it starts out where it's saying a constant. Here we're saying constant at the beginning of the day. Constant would be being the same. So you have to be careful. Sometimes we use that word constant in a different way. But there we're saying constant at the beginning of the day. So I could go with A or B, because C is going right up right at the beginning. And that doesn't work, because we want it to stay like, it's not like it started at 0 degrees and went up and then stayed constant like that. So then I look at this, and then I said the next part of this says it stayed, then it rose for several hours, and then stayed the same temperature for most of the day. Okay, so A and B, they both rise, but A doesn't stay the same temperature for a while and then drop off sharply like B does. So I would say the answer there should be B. That you should be able to say graph B was your thing. These graphs, by the way, because they're curved lines, they're called continuous graphs. Continuous graphs are basically graphs with connected lines or curves. So kind of keep that in mind. What's the difference between a continuous and discrete? Because there is an important reason for this. You're going to get some situations where you're going to have to decide, should you be connecting the dots or not? And we'll talk about that, how we would know, maybe later on. Alright, so here's another example. This one talks about theme park attendance. And on this one, you're going to notice here, like the attendance, we got the years on one side and number of people attending on another side. It is important which one, number of people attended and years. It is important to know which one's on the, let's say, up and down axis, which one's on the one that goes across, because we'll talk about those later when we talk about independent and dependent. But this one you can see here, this is what is called a discrete graph. This graph basically is saying that we can't connect the points, because from year to year, like we're getting year-end totals. So we don't want to connect the points, but we do see something here. Like we can see from overall, you should be able to notice overall the theme park is losing attendance over the years. But it looks like, say, from here to here, that these 2 years, they're the same. So it would appear that they didn't lose that much attendance, or even here to here, it looks like it went up a little bit. But overall, it's going down, if you look at it like that. So we can tell that's a graph that's going down. That means that overall, the park is losing people year to year, which means they're losing money. So keep that in mind. Year to year. So that would be something very important for the park to take notice of, because then what do they maybe need to do? Maybe they need a new ride to help to regenerate some figures or bring in people. Or maybe they have to find out a different way to bring in more people. Maybe change their pricing or something. Okay, so let's look at the Cartesian coordinate system. We use this to graph relationships between two quantities. So you already kind of saw that there, where we looked at graph A, graph B, graph C, and also where we looked at theme park attendance. But again, Cartesian coordinate system actually means, and this definition is going to go away, so you may want to pause this, but it means this. We have an X and Y axis, we have 4 quadrants, and you can see here, quadrant 1, you got a positive for both X and Y. Quadrant 2, the x is negative, but the y is positive. Quadrant 3, the x is negative, the y is negative. Quadrant 4, x is positive, y is negative. And in the very center, we have the point 0, 0, which is called the origin point. So kind of keep those things in mind. Now also, make note of that y and f of x are the same thing. So that means not only could you say x comma y, that was horribly written there, you could easily just say x comma f of x. Okay, and what that means is f of x means a function of x. Okay, that's going to become more important in the later stages of this this unit as we get to later stuff in the next few tests. Okay, so here's some definitions. A relation is a set of ordered pairs, points. So when we're looking at a bunch of points together, that's a relation. So if you went back to, say, here, these points right here would be considered a relation. And now let's go back. Domain is the set of all x values in a relation. The range is a set of all y values. And a function is a special relation where each domain value has only one range value. In other words, like you could say, there's only one x. If you see x repeated, this is not a function because that means x has two y answers. Keep in mind that this goes from the domain goes from left to right, while the range goes low to high, up and down, or down and up, however you want to look at it. Alright, so let's look at this. Some different ways we can represent a relation. We can represent it with a table. So I gave you a table example. You can represent it with a graph. Again, what type of graph is that? That is a discrete graph because I'm not connecting the points. And there may be a reason why I'm not connecting the points. And then there's mapping where I can draw, like here's my x, here's my y, and I'm connecting. That's telling me that I have these points, like here, this is 1, 10, 2, 8. So by connecting these together like that, I can tell which point is which one goes with which one. Okay, notice here, since this is discrete, I wrote the domain like this. What is the domain of this relation? And look how I did the range. Now, is this a function? Notice, there's only one x value, and for each of those x values, there's only one y value to go with it. So yes, this would be considered a function. But again, these are just three at the beginning saying how we can represent everything. So here's a graph. We're going to decide also if this is a function. This is a continuous graph. Is it a relation? Yes. No matter what, everything's a relation. That should be a given. Is it a function? No. This is not considered a function. Why? The reason why is because, look, you can see here. Let's just take these 2 points. That's supposed to be 0, 6. This is 0, -5. If you notice here, I have x 0, 0, y 6, -5. I have the x, that one x, 0, representing having two answers, two y values, and it's only supposed to have one. So because this 0, you can see this even from a mapping, 0, let's try that a little bit better. 0, I have a funny feeling I need to be here. 0, 6, -5. Instead of going to 1, it's going to 2 things. So that's why this is not a function. But even if it's not a function, we can still say it's a relation, and we can still find a domain and range. Now, this one's continuous. So because it's continuous, you're actually going to draw this a little differently. And hold a second. Let me actually erase a little bit here so you can see this a little bit better. So let me erase this here, this point. And now let's look at this. When it is a domain or a range of a continuous function, you're going to write your x and y's like this, where you can tell me what is to the left and to the right for the domain, what's the furthest to the left, what's the furthest to the right the graph goes, and what's the low and the high. It won't change. The inequalities will stay like this. Do not worry about anything other than that. Now, where's the furthest to the left? -5. What's furthest to the right? +5. Lowest? -5. Highest? +6. And there's my domain and range. There's a lot more we can cover with this, but that's all I'm going to go over for this for now. I will probably add more to this as I need to, so kind of keep that in mind. Thank you so much.